Determine the distance from the point 3, 5 to the line given by the equation 2x plus 3y minus 14 equals to 0, measured parallel to a line having a slope of 1 over 2. Okay, let us begin. First, we'll try to understand the problem graphically. Now here we have the xy coordinate plane and we have a line L whose equation is given to us. So that's 2x plus 3y minus 14 equals to 0. Then we also have another point. So the point, let this point be 3, 5. We're again denoting by A. So here our task will be to determine the distance between this point and the line L. But then we also have to make sure that the distance that we measure, it must be parallel to another line which is going to have a slope of 1 over 2. So let's say we have a line. So let's say this is the line L prime. So we have the line L prime and the slope of this line is given to us. So the slope equals to 1 over 2. So that means what we will do is we're going to draw a line from the point A to the line, original line L. So let's call it, let's say it meets the line L at the point B. So our goal will be to determine here the distance AB such that this line segment AB, it is parallel to the line L prime whose slope is given to us. Okay, so how shall we begin? So for this, what we'll do is we'll take the help of the distance form of a line. Now we know that the distance form of a line is given by x minus x1 divided by cosine of angle alpha equals to y minus y1 divided by sine of the angle alpha equals to r, where r is the distance between the 2 points. That means here we have 2 points. One of the point that is having the coordinates x comma y, and the other point has the coordinates x1 comma y1. Fine. So let's say we join these 2 points. We have these 2 points joined, and the distance between these 2 points, that's given by r. And also this line is making some angle alpha with the positive direction of x-axis. So that is the angle alpha here. So this is referred to as the distance form of a line. So we'll take the help of this distance form to find out the distance r. Okay, so how shall we do that? So here, since we have two lines, we have the line L prime and we have the line L. We'll consider that line which is passing through 2 points. So here, let us consider the line segment AB. Now, when we consider the line segment AB, clearly it passes through the point A and it passes through the point B. We already have the coordinates of point A. What we need is the coordinates of point B. So we'll assume that the coordinates of point B, that's equals to x comma y. So what we'll do, we're going to apply the distance form to the line segment AB. So what we need here is x minus x1. So let's say x1 and y1 corresponds to the coordinates of point A. So x minus 3 divided by cosine of angle alpha. This is going to be equals to y minus y1. So y1, that's 5 divided by sine of the angle alpha. And let's say this is equals to r, where we are considering r to be equals to AB, and that's exactly what we need to obtain here. We need to find out the length of AB. Okay, now in the next task, what we'll do, we can rewrite the equation as x minus 3 over cosine of angle alpha, that is going to be equals to r. Also, we can say that y minus 5 divided by sine of the angle alpha, that's equals to r as well. So that means x can be also expressed as 3 added to r cosine of angle alpha, and y is going to become 5 added to r sine alpha. So here what we have done is we have taken the coordinates of the point B, which was x and y, and we have converted into its parametric form. So here r is the parameter. So x, we are, now that we have the coordinates of x and y, our next task will be to determine the value of cosine alpha and sine alpha. Fine. Now here it's given that the slope of the line L prime, that's m equals to 1/2. If the slope of the line is L prime, then slope of AB must also be 1/2. That's because these two lines are parallel to each other. And if and we know that two parallel lines have got equal slope. So here we can say that according to the problem, here we can say that slope of AB, that's going to be equals to the slope of the line L prime. Now slope of L prime, that's given to us, so that is equals to 1/2. Now slope of AB, that is also defined as the tangent of the angle alpha, where we are considering alpha to be the angle that the line segment AB makes with the x-axis. That means if we extend B, if we extend the line along B, then this is going to make an angle alpha with the x-axis. So we have tangent of alpha equals to 1/2. Now using this, we will try to find out the value of sine alpha and cosine alpha. So for this, let us consider the right angle triangle ABC. We have the right angle triangle ABC, which is right angle at B, and angle C corresponds to the angle alpha. Now what is tangent of alpha? We know that tangent of alpha, this is simply defined as the opposite to that of the adjacent. That means AB over BC, which means that since AB over BC, that's 1:2, it's in the ratio 1:2. So AB is going to be 1 and BC, that's going to be 2. And when we apply the Pythagoras theorem, we can easily find out the length AC, and that's going to be square root of 5. So now using this triangle, we can easily find out sine alpha as well as cosine alpha. So what is sine alpha? So sine alpha, that's opposite, which is AB, divided by the hypotenuse, that is AC. So we have sine alpha, that's going to be equals to 1 over square root of 5. And we have cosine alpha defined as the adjacent, that is BC, to that of the hypotenuse, which is AC. So cosine alpha, this is going to be equals to 2 over square root of 5. Okay, so we've obtained the value of sine alpha and cosine alpha. Let's substitute this back into the parametric form of x and y. So we now have, so x is going to be equals to 3 added to 2 times r over square root of 5, and y is going to be equals to 5 added to r over square root of 5. Okay, so what we have done is we have obtained the coordinates of the point B in its parametric form. So let's note it down. So we have coordinates of, we can write hence coordinates of B. So that is going to be 3 plus 2r over square root of 5, and the y coordinate is going to be 5 plus r over square root of 5. Okay. So now that we have the coordinates of point B, we can make use of the fact that the point B lies on the line 2x plus 3y minus 14 equals to 0, which means that it must satisfy the equation of that line. In other words, what we'll do, we'll take the equation of the line 2x plus 3y minus 14 equals to 0, and in place of x and y, we're going to substitute it with the x and y coordinate of B. That means the parametric form of B that we have obtained, we're going to place in, put them in place of x and y into the equation of the line. So now we are going to get 2 times 3 plus 2r over square root of 5 added to 3y. So y is going to be 5 plus r over square root of 5 minus 14 equals to 0. Okay, so let's simplify this, and this is going to help us obtain the value of r. So we have 2 times 3, that's 6, added to 2 times 2r over square root of 5 gives us 4r over square root of 5. Added to 3 times 5, that's 15. We have 15 added to 3r over square root of 5 minus 14 equals to 0. So this is going to be equivalent to, so we have 7r over square root of 5 added to, so 15 minus 14, that's positive 1, and 6 added to 6 is going to give us positive 7 equals to 0. So let's solve for the value of r. So r comes out to be equals to negative square root of 5. However, what we need here is only positive value, so we'll consider r to be the absolute value of negative 5 because r corresponds to a distance. So we are going to get positive square root of 5, and that is going to be the length AB. So here we have successfully obtained the distance. We can say thus the length of AB, that is going to be equals to square root of 5 units. So that is our final value.